An agent that works once has proved almost nothing. It proved the prompt, the model, the tools, the data, and the random path through the task all happened to line up one time. That is useful. It is not reliability. This is where people get evals wrong. They treat an eval like a final exam for the model. Ask a question, score the answer, ship if the number looks good. That can work for simple question answering. It breaks down fast for agents. An agent is not just producing an answer, it is making decisions. It decides what to read, which tool to call, what to write down, when to stop, when to ask for help, and sometimes whether to touch a real system. The final answer is only the receipt. The behavior is the thing you need to evaluate. An eval is a repeatable way to ask, did the system do the right thing under the conditions we care about? Not in theory, in your product, with your tools, against your data, under the failure modes that would actually hurt you. For an agent, a useful eval has 5 pieces: the task, what the agent is supposed to do, the environment, the files, APIs, memory, tickets, docs, or database state the agent can see, the rules, what it is allowed to touch, what it must not touch, and when it has to ask for permission, the expected behavior, not just the final answer, but the important steps it should or should not take, and the trace, the record of what happened while the agent was working. Without the trace, you are mostly grading vibes. The agent might land on the right answer for the wrong reason. It might skip a source, call the wrong tool, recover by accident, or make a dangerous write before the final response. If all you grade is the final message, you miss the part that matters. Software tests check deterministic code. Same input, same output. If the function changes, the test catches it. Agents are messier. The model can choose a different path. The tool output can change. Retrieved context can be missing, stale, or too long. The agent can succeed at the top level task while violating a rule in the middle. That is why agent evals need to look more like operational drills than unit tests. A unit test might ask, did this function return true? An agent eval asks, when the user asks for a risky account change, did the agent identify the risk, read the policy, ask for confirmation, avoid leaking private data, and leave a clear audit trail? That is a different kind of test. The simplest useful agent eval loop looks like this. Take a real task your agent is supposed to handle. Freeze the starting state. Run the agent. Capture the trace. Score the outcome and the behavior. Then put that task into a regression set so the next prompt change, model change, tool change, or memory change has to pass it again. The last part is the point. Evals are not a one-time report. They are a guardrail against accidental regression. When you change an agent, you need to know what got better, what got worse, and what quietly stopped working. Quiet failure is the dangerous one. A crash is obvious, a timeout is obvious. A wrong answer that sounds confident and lands in front of a user is much harder to see. Good evals are designed to catch that kind of failure before production does. The first layer is the outcome eval. Did the agent accomplish the task? If the user asked it to summarize a support thread, did the summary include the actual customer issue, the relevant timeline, and the next action? If the user asked it to update a configuration file, did the final file contain the intended change and nothing extra? If the user asked it to research a library? Did it cite current docs instead of guessing from memory? Outcome evals are important because they measure the thing the user wanted, but they are not enough. An agent can get the right final output while doing something unacceptable along the way. It can use a forbidden source. It can hallucinate a citation. It can make an API call before confirmation. The outcome can look fine while the process is broken. A process eval checks how the agent got there. It looks at the trace. Which tools did it call? Which files did it read? Did it search before guessing? Did it ask for clarification when the request was ambiguous? Did it avoid a destructive action until approval? Did it stop after enough evidence, or did it wander through irrelevant context? This is where agent evals become useful. Imagine an agent that can update billing settings. The final answer says done. That is not enough. The trace needs to show that it found the right account, checked the current billing state, recognized that money was involved, asked for confirmation, made the exact intended change, and recorded that change. If it skipped confirmation, changed the wrong customer, or acted without verifying the account, the eval should fail. The process is part of the product. Safety evals for agents are often described as policy checks. That is too small. For an agent, safety includes tool boundaries, data boundaries, permission boundaries, and user intent boundaries. The agent has to know what kind of action it is taking. Reading a document is different from editing a document. Drafting an email is different from sending one. Looking up an invoice is different from issuing a refund. A good safety eval puts the agent at the boundary and checks what it does. Does it ask before sending? Does it refuse to reveal private data? Does it escalate when the instruction conflicts with policy? Does it summarize the risk in plain language instead of hiding behind generic refusal text? The eval should not only ask, did the agent say the safe thing? It should ask, did the agent behave safely when the tool was available? A lot of agent eval systems use an LLM as a judge. That is useful. It is also easy to abuse. An LLM judge can compare a response to a rubric. It can inspect a trace. It can flag missing evidence. It can say whether the answer followed the instruction. But the judge is not the ground truth. The ground truth is the task definition, the environment, the policy, the expected state change, and the human labeled examples you trust. Use a judge to scale judgment, not to invent it. Start with examples a human has labeled. Write down why they pass or fail. Then use the judge to apply that rubric consistently across more runs. And test the judge too. If the judge rewards long answers, the agent will learn to be verbose. If the judge misses unsafe tool use, the eval will pass dangerous behavior. If the judge only sees the final answer, it cannot grade the trace. Judge drift is real. Treat the judge like part of the system, not a magic scoreboard. Do not start with a giant benchmark. Start with the 20 tasks that would embarrass you if the agent got them wrong. The account change that touches money. The support summary that could mislead a human. The code edit that could delete data. The research answer that could cite the wrong source. The personal task that should ask before sending a message. These are not random examples. They are the shape of your risk. For each one, create a fixture. Freeze the inputs. Write the expected behavior. Run the agent. Capture the trace. Score the result. Then keep those tasks forever. Every time you change the system, rerun them. That gives you a baseline, not a perfect measure of intelligence, a practical measure of whether your agent still does the work you trust it to do. A single score is comforting. It is also lossy. If an agent goes from 82 to 86, what changed? Did it become better at retrieval? Did it get faster? Did it become more reckless with tools? Did the judge become easier? The number does not tell you. A useful eval report should show examples. Show the task. Show the expected behavior. Show the trace. Show the pass and fail reason. Show the diff from the last run. For agents, the diff matters. If the old agent asks for confirmation before a write and the new one does not, that is a regression. If the old agent read the policy and the new one guesses, that is a regression. If the new agent solves the task with fewer tool calls and the same evidence, that might be a real improvement. The score is the index. The evidence is the product. Agent evals fail in predictable ways. The first failure is clean room tasks. The eval asks perfect questions, gives perfect context, and avoids the messy cases that happen in production. The agent passes the eval and still fails real users. The second failure is answer-only grading. The final message looks good, so the run passes. Meanwhile, the trace shows missing sources, unsafe tool calls, or lucky recovery from a bad plan. The third failure is benchmark overfitting. You tune the prompt until the eval set passes. Pickup. You tune the prompt until the eval set passes, but the behavior does not generalize. The agent learned the test, not the work. The fourth failure is untested change. Someone swaps the model, changes the system prompt, adds a tool, updates memory, or rewrites retrieval. The agent still feels the same in a demo, but a behavior changed underneath. The antidote is not a bigger scoreboard. The antidote is a small set of hard, realistic, trace-based evals that run whenever the agent changes. A good agent eval system is boring in the right way. It runs the same important tasks again and again. It records what the agent saw and did. It checks outcomes, process, and safety boundaries. It shows concrete failures instead of hiding them behind a score. It gets updated when production finds a new failure mode. The last piece matters. Every real failure should become a future eval. If the agent sends before approval, add that case. If it trusts stale context, add that case. If it writes to the wrong file because two names look similar, add that case. If it gives a polished answer without enough evidence, add that case. This is how evals become a reliability system instead of a report card. You are not trying to prove the agent is smart. You are trying to prove the agent still behaves correctly when the situation changes. Here is the practical starting point. Pick one workflow your agent is supposed to own. Write down 10 normal tasks, 5 edge cases, and 5 tasks that should trigger caution. For each task, define the starting state and expected behavior. Run the agent, save the trace, label the run, pass, fail, or needs human review. Then change one thing: the model, the prompt, the tool list, the memory, the retrieval corpus. Run the set again. Now you have something useful, not a benchmark headline, a regression harness for your agent. Over time, add failures from real usage. Keep the set small enough to run often. Keep it realistic enough to hurt when it fails. That is the point of evals for agents. They're not there to make a demo look scientific. They're there to catch quiet failure before a user does. Agent evals are not mysterious. They are disciplined receipts. The task was this. The starting state was this. The agent did these things. The result changed this way. The behavior passed or failed for these reasons. Once you see evals that way, the whole subject gets simpler. You stop asking whether the agent is generally good. You ask whether it can do work you are about to trust it with. That is the only eval that matters.